Hello guys, this is the recorded lesson for Monday. Hopefully if you are in band you are watching this lesson, or if you were absent on Monday you're watching this lesson. First of all, I'm showing the answers to this worksheet right here. It was called More Special Segments, and this was Friday's homework. So last Thursday, our lesson, we learned about special segments: median, altitude, perpendicular bisector, angle bisector. So you had a homework on that, and then you had a second homework over that, which also reviews you over some logic and constructions and all that good stuff. So here's the answers to that. Go ahead and pause this for as long as you need and check your answers. Here's the answers to the back with all of those sentences written out. Remember, we care about the truth value of these, making sure you know how to determine. And believe it or not, what did you find? They were all true. All true. All right, go ahead and pause the screen if you need to look at it longer. All right, so today we're going to add in one more special segment number 5. Here's a picture of our special segment. Let me introduce you to ED as our new special segment. What do you notice about this special segment? Kind of looks like a median, doesn't it? Except a median has to go through a vertex, and this one definitely does not go through a vertex. What do we know about point E? Well, point E is a midpoint because we see those markings on either side of point E. What do we know about D? It is also a midpoint because we see congruence markings on either side. Now, we're not saying that those markings are the same length. For example, this could be 4 inches, 4 inches, and this could be 7 inches, 7 inches. But we do see that E and D are both midpoints. So segment ED is a segment connecting two midpoints of a triangle. And it has a specific name. You can write this in your notes or commit this to your memory. The new word is midsegment. So now we have altitude, median, angle bisector, perpendicular bisector, and midsegment makes 5. The segment connecting the midpoints of two sides of a triangle. Now, how many midsegments would a triangle have altogether? Well, a triangle has 3 sides, so a triangle is going to have 3 midsegments. Pause this if you need longer to write down the definition. We are going to skip the investigation for the recorded lesson, although I'll be doing it in class. When my students do this investigation, they are going to draw a triangle. Then they're going to find the midpoint of each side of the triangle. Their triangle doesn't have to be perfect. It doesn't have to be equilateral. This happens for any triangle. Then they're going to draw all 3 midsegments. And then they're going to realize something. They're going to realize that when we draw all 3 midsegments of a triangle, it divides the triangle into, oh my goodness, 4, let's see if it lets me rotate, 4 congruent triangles. I just took all of those light purple triangles out of there. I put them on top of each other, and there's nothing overlapping. There's nothing showing. So all 4 triangles are congruent. So it divides a triangle into, why did I not put 3? 4 congruent triangles. There we go. So that's one cool theorem about a midsegment. Now, that triangle was perfect. I will admit that one was equilateral. So does it still work if your triangle is obtuse or irregular, scalene? And let's see if it does work. If I could grab these correctly. 1. And see, even though this triangle is not equilateral or isosceles, the theorem is still going to work. And if my alignment was on, that would really help. Da, 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 da. So all 4 of those are the same exact triangle. Cool theorem. The 3 midsegments of a triangle divide the triangle into 4 congruent triangles. Pause this if you would like to write that down. How do you think the length of the midsegments compares to the length of the base? Now, when I say the word base, not all triangles have a base. When I say the word base, I mean the side that is the base compared to the midsegment we're looking at. So when I say base, when I'm referring to segment DE, its base is BC. There's something else I can call it, but we haven't learned that yet, so I'll tell you that in a minute. So how long is DE and how long is BC? Well, how many DEs does it take to make one BC? Let's see if I can grab one. My alignment's off, so it's not letting me grab one. But if I could grab one, here, I'll just do this. There we go. If I measured it and then I compared, look at that. 1, 2. It takes 2 midsegments to fill in the base. So here is the triangle midsegment theorem. The segment joining the midpoints of two sides of a triangle is, this is what I couldn't say earlier, it's parallel to the third side, and its length is half the length of that side. So 2 jobs that a midsegment has to do. Number 1, it's always parallel to the third side. So DE is always has the same slope as BC, always parallel. And if I double the length of DE, I will have the length of BC. So here's that theorem summed up in 2 math statements right there. The triangle midsegment theorem. Not only is it parallel to the base, but it is half the length of the base, or the third side. All right, let's solve a few problems. If AC is 20, then DE is, well, by the triangle midsegment theorem, DE is half the length of the base. So DE is 10. If BE is 6, then BC is, well, if BE is 6, we know a midsegment connects midpoints. That means E is a midpoint. So that means this is 6, and so BC would be a total of 12. If DE is x plus 6 and AC is 3x plus 4, then x equals, well, what we would not do is set those equal to each other, because we know by the midsegment theorem that the midsegment is half of the third side. So what I could do is double the midsegment. 2 of these will equal AC. So I could double the half to equal the whole. 2x plus 12 equals 3x plus 4. Subtract 2 from both sides. We've got x, subtract 4. Look at that. X is 8. Final answer. We could plug it back in and find the missing signs. Okay, now, in all of these examples, I've been giving you the one that's kind of like facing you. The one that goes like this, and then its third side is like this. But we could also use the other midsegments of the triangle. TE is also a midsegment. So we could look at TE. That's the one that's parallel to X. So to find X, we're not going to use 21. Don't use that side. That's not the side that's parallel. You can only use the side parallel to the side you're trying to find its length. So we're going to take 25, and we're going to double it. So the answer was 50. X is 50. UA is 24. TN is 6. UT is 8. Find the perimeter of UPA. So we're going to find the perimeter of UPA, so the distance all the way around that triangle. Now we already know one of the sides, it's 24. We can easily find this side, 8 and 8, for a total of 16. What about that third side? Well, we can use his midsegment to help. TN is 6, so that makes PA double 6. It makes it 12. So 16 plus 12 plus 24. The perimeter is 52. Could we find the perimeter of T and E? Absolutely. Let's see if we can find that. What is NE? Well, it's half of 16. You look at the side that it's parallel to. So it's 8. And what's TE? Look at the side that it's parallel to, 24. It's half of 24. So we could add those numbers up. Let's just do that because I want to see the connection. 12 plus 8 plus 6. 26. How does TNE, that perimeter, compare to the perimeter of UPA? How is 26 related to 52? Of course, if each segment is half of its parallel side, then the perimeter is going to be half of the perimeter as well. 26 is half of 52. All right. This quiz we moved to Tuesday, so all of our band students could participate in that quiz. The quiz is over special segments: median, altitude, perpendicular bisector, and angle bisector. Your homework is called Midsegments. It's just a little half sheet. Have a great trip, and we'll see you all on Tuesday.